Hi, my name is Emily Volovic.
My name is Harvey Willing.
I'm Anna Lowe.
And I'm Alex King.
For this study, students were tasked with investigating how two quantitative variables influence one another and how they are associated.
Being Los Angelinos, our group naturally decided to research the complicated financial and business relationships of the Hollywood film industry.
We focused our analysis on the relation between the total promotional costs of movies in millions of US dollars and the first year box office receipts of those movies in millions of US dollars.
Promotional costs for movies include advertisements on TV, billboards, celebrity appearances, and interviews.
Box office receipts refers to the money generated by movie ticket sales.
Powerful Hollywood producers are eager to understand how the total promotional costs of movies affect the first-year box office receipts.
The explanatory variable of the study focuses on the total promotional cost in millions of US dollars associated with movies, while the response variable focuses on the first year box office sales, also in millions of US dollars. The response variable is the variable that is affected by changes in the explanatory variable. In scatterplot, the explanatory variable is plotted on the horizontal or x-axis, and the response variable is plotted on the vertical or y-axis.
The scatter plot shows specific data points in relation to each other and individually. It also allows one to visually detect any patterns or trends in the data. When the scatter plot includes the least square regression line, the linear trend is more easily observed. Comparing the data values to the least square regression line allows one to determine the residuals and assess the accuracy of the predictions. Most of the residuals in this data set are small, and the scatterplot dots are close to the least squares regression line. So the least squares regression line is very accurate most of the time.
The differences between the actual first-year box office receipts and the predicted receipts, the least squares regression line's y values, are called residuals. The larger the absolute value of a residual, the less accurate the prediction from the least squares regression line, and the higher the variability. On the residual plot, we can see that most of the residuals are small because the dots are close to the horizontal dividing line. So the least squares regression line are fairly accurate most of the time. For example, the X value of $2.1 million has a residual of only 0.4321, which is relatively small. However, for one X value, $7.6 million, the absolute value of the residual was extremely large at 28.4474. So the least squares regression line was not accurate in that moment. Since there was only one problematic value though, it is safe to say that most of the variability, 86.48%, can be explained by the least squares regression line. Because there is no pattern in the residual plot, the linear model is appropriate.
Correlation coefficients are used in statistics to measure how strong a relationship is between two variables. The closer the value is to 1, the stronger the positive linear relation. Therefore, the correlation coefficient of this data, R equals 0.292997, indicates a strong positive linear relation between promotional costs and first-year box office receipts of Hollywood movies.
The linear regression equation associated with the Hollywood movies' first-year box office sales and promotional costs is y equals 12.669 times x plus 23.163. The slope of this equation is 12.669. which means that for every increase of $1 million in total promotional cost of a movie, there will be an approximate increase of $12,669,000 in box office sales. This means that Y, which is the response variable, will vary depending on the value of X, which is the explanatory variable. The y-intercept is 23.163, which means that when the total promotional costs are 0, the first year box office receipts will be approximately $23,163,000.
The coefficient of determination, r squared, was 0.8648, which means 86.48% of the variability in the first year box office receipts in millions of US dollars is explained by the least squares regression line. This demonstrates that a high percentage of the time the least squares regression line can be used to accurately predict an estimate of the first year box office receipts in millions of US dollars. When given the total promotional costs for a movie in millions of US dollars. So the model is a good fit for the data.
So, to conclude, there is a positive linear relationship between the total promotional cost in millions of US dollars and the first year box office receipts in millions of US dollars.
There is no pattern in the residual plot. Thus, a linear regression model is appropriate.
The least squares regression model does do a good job in explaining the data set.
The coefficient of determination, the correlation coefficient, and the residual plot all indicated that the linear model would apply to this dataset.
There is also no outliers in this dataset. Thank you for listening to our group presentation.